Hello and welcome. My name is Andrea Hall and I am the customer care representative here at Saratech and I will be your host today. We are fortunate enough to have Ernesto Menino here and he is going to be talking about a groundbreaking optimization platform called Cameme, and he is from Cyberdyne. But first I'd like to quickly tell you a little bit about Saratech. Well, first let's take a look at Ernesto and you can introduce yourself.
Oh, yes, of course. Hello, everyone. My name is Ernesto Menino. I'm CEO and co-founder of Cyberdyne, and today I will be your guest doing this presentation talking about optimization and KI application of optimization.
Okay, and like I said, let me tell you a little bit about Saratech. For over 15 years, we've been teaming up with our customers to help optimize their processes across their design, analysis, manufacturing, and quality systems. We're an industry leader in the PLM space through our partnership with Siemens, and we are their #1 partner in the Americas. We are headquartered in Orange County, California, and our team of professionals has grown dramatically over the years, and we are located all over the U.S. So that we can be a little closer to our customers. Next slide. Please enter all your comments and questions during the webcast in the chat box over to the right, and we will be sure, normally we answer them at the end of the webcast, but if you have any questions or comments during the webcast, Ernesto has given me the okay to go ahead and interrupt him, and we can get those questions answered on the spot. And then after the webcast, if you wouldn't mind, please stick around for about 30 seconds or so and fill out a quick survey, just a couple of questions. We'd really appreciate your feedback. And now I'd like to hand the reins over to Ernesto.
Okay, thank you very much for your introduction. So this is the agenda of this presentation today. We're going first to see what is optimization actually, in order to be sure to stay on the same page about optimization and the application of this technique to computer-aided engineering. And then I will present you Cameme, which is this new groundbreaking platform for the solution of optimization problems with the 3 key features of Cameme, namely process integration, process automation, and the possibility to use Cameme also on the cloud as a service on the web. And finally, I will show you live Cameme, solving a couple of real-world problems, both on-premise, so with an installation on a real computer, and on the web using our software as a service version of Cameme. So we can actually switch to our presentation here. As I was mentioning before, I'm CEO and co-founder of Cyberdyne. Cyberdyne is a company focused on the application of artificial intelligence techniques and mainly meta-heuristic optimization techniques to the solution of industrial problems. But actually, what is optimization? So optimization is actually means finding the best choice among several that can actually let you accomplish your specific goal to reach your goal in your specific task. For example, let's say we want to visit several cities across the US in a round trip, trying to save the most miles, so saving fuel as much as possible. So the best sequence among all the possibles is not a trivial choice, because actually if you have many cities, you could spend a lot of time with a computer trying all the possibilities. And artificial intelligence can be used to effectively solve this kind of problem. And the same technique can actually be used in engineering as well. For example, let's say we want to design an antenna, optimizing the electromagnetic field of this antenna, changing the shape and the size of each component of the antenna. The same technique, optimization, can be actually applied to the solution of this engineering problem in order to maximize the electromagnetic field in a specific direction, so actually accomplishing your design task. And this kind of techniques can be actually used in several different aspects of engineering, so mechanical engineering, electromagnetic engineering, and so on. In order to solve this kind of problem, we actually realized Cameme, which is this new platform for optimization, which is composed by 3 main features and characteristics. First of all, we will see what is for us process integration and how it works. By means of process integration, we'll see that it is possible to actually describe your own design task and very easily and solve it straightforwardly for your optimization. Then we will talk about process automation, which is a component built into KeyMem that can let you spread the calculation of your process across several computers in order to speed up your optimization process. And finally, we will talk a bit about all the mathematical foundation that is included into KeyMem with several different algorithms available for optimization, but also design of experiment, build up of your set, and also response surface method analysis algorithms that can be used to make your mathematical model of your specific design. So first of all, process integration. So by means of KeyMem, it is very easy to build graphically a workflow that can describe your day-by-day design activity on your specific project. As an example, we can actually see the task here of designing, changing the shape, the body shape of a car by means of, let's say, 4 numerical parameters. This is just for sake of an example. Of this example, of course, the problem can be much harder than this, and we'll see more complete problem in a meanwhile. So let's say we want to use these 4 numerical parameters in order to change the shape of this car. And we want to use, for example, a software, let's say a mesh morpher or a CAD, to change the shape of our car using these 4 parameters. Then the results of this shape, so the output of the first software, can actually be sent to a second software, let's say OpenFOAM, to accomplish a CFD simulation to see if our car is aerodynamic or not. And let's say that we are going to make some cost estimation by means of an Excel workbook that can actually let us say if the specific design at end at each simulation is, for example, expensive or not. And let's say that this cost estimation is a function of some of our parameters. So we want to actually obtain the best car possible, so the most aerodynamic car possible. So we want to maximize the performance of the CFD simulation and at the same time minimize the cost estimated by Excel. This is actually called multidisciplinary, multi-objective optimization. So this is something that every engineer every day is actually solving by hand, interacting by hand with all the tools used every day in all the activities related to the design process. And by means of process integration, it is very easy to describe all the process using this data flow paradigm, which is actually used to describe all the sequences involved in the activities for the specific project. And by means of this very easy representation of your project, so data flow representation, it is very easy to save a lot of time, saving all the time you spend day by day interacting with the user interface of your product. Namely, in order to, for example, solve the problem of the design problem we have just seen now, you should actually interact with the first software, let's say the CAD, using the interface, changing the parameters on this software, saving the files, or exporting the file in a specific format, and then move this file to another process, OpenFOAM in this case, or even send this file to a colleague of yours that has to actually run the simulation for the aerodynamic part of the project. And at the same time, you want to change the parameters into Excel, and so on. So all this single specific interaction with the software is time consuming, and by means of process integration and KeyMem, you can actually save a lot of time automating all these processes and all the process related to exchange, the exchange of information and files from one process to the other. In order to actually describe your own specific design activity, actually we integrated into KeyMem a palette of several different processes that can actually be used in the description of your project. For example, you can actually put Java code or Python code or command line interface programs such as old-fashioned style FEM analysis tools that can actually be used with input-output described into files, but also you can actually integrate higher level software programs such as MATLAB for mathematical simulation with Simulink, or Siemens AMESIM for discrete simulation, Excel of course, and then you can actually get your own software in the field of finite element analysis tools or CFD tools, for example CCM Plus or ANSYS, And finally, you can of course describe, if you have one, you can describe your changing geometry for optimization using some among the best CAD, parametric CAD on the market. Of course, we have a strong support for Siemens NX. And several other processes can be described by means of the interaction of Kimeme with the third-party software. And this palette is growing every day because actually we are capable of building a new node for this palette for your specific processes. So if you have a software that we're not already supporting Kimeme, then we can build, write the software and build this new support very quickly in order to describe your own project into Kimeme. So this is everything about process integration. We will see in a while the advantages of process integration, but first I would like to spend a few words about process automation. So Kimeme can actually be used to execute several softwares and to actually, for example, run all the simulations related to a specific project, running several softwares in sequence. And you can of course do this on your own computer. You can install Kimeme on your own workstation where the other softwares are already installed, and Kimeme can talk to these softwares to execute your simulations. This is definitely fine. You can run all your simulation using this approach. But if you have, for example, other workstations in your office, for example, few workstations with some software installed and other workstations with the other softwares available, by means of Kimeme Network, which is a component natively built into Kimeme, you can actually spread your calculation over the local area network, and you can leverage on your hardware assets in order to speed up your calculation. And if you have more computers, you can actually use all those computers with all the softwares. And of course, if you have an HPC cluster in your company, then you can actually connect your HPC cluster to these calculation networks as well in order to speed up even more your calculation. And if you have an account on Amazon Web Services, then you can actually plug your account into Kimeme Network in order to spread your calculation over the cloud, over the network on the cloud, spawning several different virtual machines on Amazon Web Services in order to run just your simulations, and then switching down your virtual machines in order to just use the computational power you need for your specific simulations. We already support several softwares of the Kimeme palette on Amazon Web Services, and this palette is growing as well. And again, everything is automatic here. So you don't have to, for example, set up shared folders or write code to say, move this file from this computer to these other computers, because everything is automatic. Kimeme is in charge of moving all the files needed for your simulation automatically, and moving just the most updated, up-to-date files. So actually, if you have big files that needs to be moved from one computer to another, but have been already copied, Kimeme is smart enough to move just the most up-to-date files. So this is everything here is very easy to use and very straightforward to be used for calculations on HPC and cloud. Finally, a few words about mathematical analysis characteristics of Kimeme. So actually, since our main expertise is on optimization, we built into Kimeme an open library of optimization algorithm based mainly on meta-heuristics, such as the well-known genetic algorithms, but also much newer algorithms such as differential evolution, particle swarm optimization, and so on. All these algorithms are very efficient in the multi-objective field, and can be also used by the user and changed by the user in order to get better performance. But also you can build your own design of experiment, or you can build your artificial mathematical model of your project in order to speed up calculations. For example, training your neural network in order to find the relations among inputs and outputs of a part of your project. And all these tools are actually integrated into the process integration and process automation tools, so you can actually optimize very easily your project, spreading the calculation over the network, as we are going to see in this demo live now. So let's say with a real world problem, let's say, let's see all these advantages of Kimeme in solving a real problem. Let's say we want to design a new wheel for a car. We can see this wheel, metal wheel is actually the object of our design activity, and we want to find the shape of this wheel, changing the cross-section of this wheel, but also the shape of all the holes here on the wheel, and the number of the wheels and the position, sorry, number of holes and the position of holes that are called actually windows on the wheel, in order to find the best wheel possible, where best here is intended as the most lightweight wheel, maintaining a strong resistance to mechanical stress for each possible mechanical weight applied to the wheel. So actually we want to change the shape of the wheel in order to find the most suitable combination of these parameters. And in this specific task, we actually imported an NX project in Kimeme by means of the node I showed you before. And we have in this project 14 parameters. So 14 geometrical parameters defined into Siemens NX that are going to be changed by means of the interaction of Kimeme with NX and other software in order to find the best combination, so the best shape, in order to save weight for the wheel, but also obtain a strong wheel. Just to give you an example of the effect of the changing of these geometrical parameters into the wheel, you can actually have a look at these animations here. We have just the effect reported in this animated picture here of 4 of these geometrical parameters. So for example, P979 is actually the width nose here on the side of the wheel. Changes this parameter, actually you can see that the shape is changing, as well as the effect of the load on the wheel by means of finite element analysis screenshot. All these screenshots have been taken by means of Kimeme, automating the process of changing the shape and submitting this new shape to a FEM analysis process by means of the experiment task. So actually, this is something that you can actually accomplish by means of Kimeme, but actually in this case, our task is to optimize the wheel. So actually, by means of the integration of NX for the change of the geometry and ANSYS for the assessment of the performance of each specific design candidate to the solution of the problem, actually we have implemented our design task into Kimeme. And so then we can actually switch to Kimeme here. As you can see, this is the main user interface of Kimeme, just a short view here to the user interface. Here on the left you can see the project view, where you can actually store all your files related to each project. For example, this very project here is contained into this folder, which is called Spline and etc. So this is our project. We can double click on the project. This is the project realized by means of project process integration. Into the folder you can see all the other files that are created during the execution of the optimization. And by means of this drag and drop interface, you can actually build your workflow design in order to describe the change of the parameters in your geometry and also the execution of the FEM analysis in order to accomplish our task. So just a brief overview of the interface here. For example, yellow icons here, as you already know, are variable icons. I can actually change the characteristics of each one of these variables, which are used to actually change the shape of the geometry here. So actually we are, for example, making mathematical operation on each of the variables by means of this calculator icon here, and then the result is actually sent here to the NX node. If I click here on the next node, in the lower part of the interface, I can actually see the properties of the node here at the end. And we can actually change here on the interface all the parameters related to the specific project. Here, for example, I can specify that this file has to be used for our project. For example, this is called wheel model spline.prt. Then I can actually open from Kimeme directly Siemens NX in order to see and to, for example, interact with my project file here directly into NX. So here we see a view of our wheel, and then we can actually, of course, interact with NX as usual. This is a full view of our wheel now. Okay. So after after the interaction with the CAD, in this case, we can actually close the CAD, go back to Kimeme, and then we can actually make the couplings between each parameter of Kimeme and each parameter of the geometrical shape in NX. So actually, Kimeme is, from this point of view, very smart, because actually it is capable of using NX to inquire, to analyze the PRT file, and to see all the list of all the parameters defined into the CAD file here. So actually, we can see all the parameters here, and we can actually choose which parameter needs changed by Kimeme, injecting the numerical parameter of Kimeme into the CAD. After this process, the CAD is changed and automatically saved. And you can see here, this type field is actually reporting Kimeme network. So actually, we can just change this option here. We are going to leave it on Kimeme network. We can change this option in order to define if we want to run this process NX on this very computer, so our local workstation, or over the network using the Kimeme network. So actually sending files and execution commands to another computer to change the geometry, and so to make a new shape. This connection from NX to the ANSYS icon here is used to actually move the file from the computer in charge for executing NX to another computer here in charge for executing ANSYS. Here again, we have a project of ANSYS. We can open the project, but we can save time here. And we can actually, by means of a macro, make some automatic operations on the imported project file here into ANSYS. And we can again make some computations on the output of ANSYS here. For example, in this case, we are calculating the mechanical stress on our design candidate here. And actually, by means of these two nodes here, we are minimizing the weight of the wheel as an output from NX and the weight and the stress of the candidate wheel as an output from ANSYS. Once we have defined all these process integration, you can of course use and reuse this kind of process in order to accomplish some specific task. For example, let's say you want to change just some parts of your wheel, and you want to design a new wheel, or you want to just see the amount of stress on a specific design. So then you can actually open your workflow, and then you can run your workflow on a specific design candidate, or you can run a whole new optimization process in order to find your solution when you are changing your conditions for your specific project. Let's say you are changing from one partner to another, for example, another automotive partner. So you have to change some characteristics of your design. You can change it easily and run it again without changing all the process integration tasks. So in this specific case, we are actually running a design experiment just to say, for sake of brevity of our presentation. So actually, by means of these algorithms, you can define your design of experiment. So the sets of parameters you want to test on your project, and then you can actually run, by means of this play button here, your task. You can name it as you want. Here we are going to put a name, let's say DOE evaluation. Okay, DOE, yes, very good. And then we can actually set here this checkbox saying that this is a multi-threading optimization, in this case multi-threading simulations, using 6 different threads over the network, because actually, as we have seen before, all the nodes are set as Kimeme network nodes. Then we can put here OK, and Kimeme is in charge here of the execution of our project. So first of all, it is sending on over the network all the files needed for these specific applications, specific task. And here we can switch to this other window, which is called the KeyMema Network Manager, which is the component of KeyMema Network that I introduced you before during the presentation. Here you can see that we have 4 different workers. A worker is actually, let's say, a service on a remote computer that is in charge for executing specific tasks. For example, here you can see that we have a worker that can actually be used to execute Python or spreadsheets or ANSYS tasks. And this other network worker is in charge of executing, in this case, an X processes. So 8 is the number of free available cores on the specific worker, and we have already seen that this worker has been in charge of executing NX. So now all the NX tasks have been completed, and now the network is executing the ANSYS process, because actually from 8 we went down to 2 available processes. So 6 concurrent ANSYS simulations have been submitted to the network here. And in a while, we are going to see here into KeyMema that this table is going to be populated by the results of all our 6 simulations that have been submitted over the network in order to accomplish our design of experiment tasks. So, as you can understand, this wall simulation is taking up to 3 minutes, more or less, mainly because of the ANSYS execution time. But actually using 6 cores at a time over the network, we can actually speed up the simulations by 6 times, actually. And if you have more cores or more processes, you can actually, of course, speed up your process even more. And then we can actually, while these tasks is actually completed, we can move back to the presentation to see the results you can obtain by means of this approach here. So in this plot, you can see several green dots, which are the results of each simulation. So on the x-axis, here we are seeing the weight of each design candidate, and on the y-axis, or the vertical axis, we are seeing the amount of stress, mechanical stress, in terms of von Mises stress measured in megapascals. So actually each green dot represents the results of one design candidate, and the optimization task here consists in finding the minimization of the stress and at the same time the minimization of the weight of our design. So actually we want to move downwards and leftwards on this picture, and so you can see that there is this kind of L-shaped curve here on the left bottom of this plot, which is called Pareto Front, and this is the result of an optimization when you have more than one goal, more than one objective. So in this very case, you have, since you have 2 objectives, you have a set of equivalent optimal solutions, and then the designer, the user, can actually choose among all these possible solutions, but he is sure that these are all the possible optimal combinations. So let's say if I can actually sustain more stress on my wheel, then I can move on the L-shaped Pareto curve on the left in order to, for example, have a more lightweight wheel. Or otherwise, if I want, if I can actually design a wheel with a more weight, then I can move right-wise in order to spare and to save on the stress aspect of my project. By means of KeyMema Network, and so the execution of this project over 4 workstations in the case of the optimization, it is possible to actually execute this project in just 3 hours of calculations, and the results is actually reported here, because by means of the optimization it has been possible to move from the initial solution, which was the original design candidate for this customer of Cyberdyne, left to the optimized solution using the same amount of stress, mechanical stress, and saving 15% of weight for the final design candidate chosen for the production phase. So this is one of the main key selling point of Kimeme. First, of course, you can describe your process and automate it over the network in order to save time. Second, by means of optimization, you can actually change your design activity into an optimization task, and you can actually get better results, so better products after a quite quick time of optimization using Kimeme and its advanced optimization algorithm. So actually, we cannot just move forward. You can see here that the process has been completed in 3 minutes roughly, and in the table here we have the results of all the 6 sessions we have run on our network. So of course, if we had wanted to run a full optimization, we had to wait for 3 hours, but this is just to give you an example of the distribution of calculation over the network. And as I mentioned before, Kimeme is also a web application. So actually you can use Kimeme directly from your web browser as a service. You can submit your optimization task directly into your web browser. You can actually submit calculation tasks using your Amazon Web Service account or your Penguin Computing account if you have one over that cloud service provider. Or you can actually make VPN with your own local area network in order to submit processes on your very computer. So I'll show you quickly Kimeme on as a service on your web browser. So as you can see here, this is a Chrome web page. You can actually request a login here, and you can actually access this virtual space on the web. This is actually a virtual desktop where you can actually organize all your folders and files in virtual folders. As you can see here, you can actually use this virtual space as, let's say, a la Dropbox. So actually you can share this folder, this space with your local folder on your computer, and into this virtual space you have here Kimeme, the very same Kimeme you are used to your local installation here. And in this case, actually, we can see a very simple project with just Java code that is in charge of realizing a very simple optimization project here. Very quickly, let's say we want to design a cantilever beam, changing the shape of the cantilever by means of A and B, which are the weight and the width and the height of this cantilever beam, and we want to minimize both W, which is the amount of space which is bending, by which is bending the cantilever, and as well as we want to minimize the weight of the wheel. And let's say in this case we want to use just plain formulas, and so we want to find the combination of A and B that minimize these two numbers. In this case, we are using formula just for sake of the demo in order to accomplish the task very quickly. But of course, in a real application, you could actually put your calculation software here, for example, FEM or CAD analysis instead of Java software. So actually, you can drag your icons. These are variables. These C are constants here. These are constraints for our project as defined in the problem previously. The output of this node is the mass. This output is the bending amount, and we want to minimize both mass and the bending amount. We can actually associate to the project an algorithm here. Here we have already associated mode, which is multi-objective differential evolution, but you can choose one among several possible algorithms directly implemented into Kimeme, and then you can again run the project into your web browser here directly by running it. Yes.
No. We have a question.
Yes, of course.
Okay, sorry to interrupt you. Someone wanted to know how can I share project files and data with my team or my colleagues?
Oh, okay. So actually, as you can see here on the cloud, you have your workspace of Kimeme here with all your projects and files, and you can share this space, so this project folder here, both on your local computer, because here you have a folder which is called Kimeme Workspace, which is the same folder that Kimeme is using here, or you can, on another account of Kimeme, link the same folder, so sharing the project among several users. So you can actually move files from your computer, local computer, to your account online and back, and share files among several accounts. And this is very easy. So actually, by means of this approach, you can actually implement a sort of, let's say, co-working, co-design approach to your optimization. For example, you can optimize one aspect of your project and then save the results into this cloud space. And a colleague of yours, using his own account, can connect, import the results from the optimization, and use those results in his own optimization tasks. Okay. And this is very straightforward.
Great, thank you.
Okay, so just to complete my demo very quickly, here, these are the results of our optimization. This is the table containing all the candidates for our optimization. So actually, we can filter our results here. For example, we can get just the unique solutions here, and then we can plot all the feasible solutions here, just to see just the solutions that are complaining all the constraints, and then we can make, for example, a scatter plot to see the results of our optimization. Just to give you an example of how easy Kimeme is in solving this kind of problem. So here we are with the results of our optimization. So we can make a zoom here, and we can actually see the results of our optimization. Again, we are seeing here a Pareto front here, which is the best combinations for all the candidates. Here we can see that, for example, this candidate design has a mass of 1.04 kilograms and a bending amount of 1.15 millimeters and so on. So actually, at the end of the optimization process, you can assess and make a decision about the most suitable design results for your specific task, or you can start again with making some changes on your specific project. And again, everything here you are seeing is into your browser. So actually you can use Kimeme and make your own optimization in your browser, locally or with your network approach, or even on the cloud. For example, if I put my information about my Amazon Web Services account here, which I didn't actually, and I define this Java process as an HPC cloud process, and I run the process again, then this task will be sent to Amazon Web Services to make the specific execution. And if I make a multi-threading, let's say 1000 process optimization, then I can actually configure Kimeme in order to spawn 1000 virtual machines on Amazon and to speed up the calculations. And for example, if you are using the open source software for CFD, such as OpenFOAM, then this kind of approach can be very effective, because you can actually leverage on the openness of OpenFOAM and spawn as many workstation, virtual remote workstation on Amazon as you want to speed up your simulations and calculations. So actually this completes my presentation, so we can go back to the first presentation here.
And actually,
yes. So summary.
One question did come in. Someone said, I already have some optimization code developed in-house. Is it possible to use that with Kimeme?
Yes, definitely you can. I can show you among the several possible views into Kimeme here, it's possible to change and modify algorithms used in your specific optimization tasks. This is something we usually do show during our demo, because it is an advanced feature, but it's very used by some of our customers, because it is quite often to have some already developed in-house algorithm for your specific problem. if you have a specific problem that you know very well and you already have some expertise in optimization, then you probably developed well-defined, tailor-defined algorithm for your problem. And then maybe you could be interested in coupling your algorithm with our process integration and process automation features. So actually, by means of this approach here, you can define your own algorithm and define all the pieces of code. Each one of these piece is actually open source. This is Java code, this is Python code. You can actually edit directly from Kimeme your code here. For example, here you can see that this is the source code in Java for one of our algorithms. You can actually link into this very piece of code a call to your own code, and then you can integrate our platform to your own optimization algorithm and expertise, leveraging on both and actually obtaining better results than before.
Okay. Thank you.
Oh, yeah, welcome. Thank you for the question. It's a very interesting question. And so, summary, just to conclude our presentation. So, as you can see, Kimeme is a groundbreaking platform for CAE optimization because of its features, mainly because it's cloud-based and it's a completely novelty in the field, because we are the first optimization platform that can natively support cloud systems such as Amazon Web Services or Penguin Computing. We can support your own in-house CAE products. So if you have already, for example, products from Saratech, such as NX, or if you have other products that are not already supported, we can put it in our palette in order to make the workflow for your own project very easily. And if you want, you can actually use it as a service, so not buying a license, but actually renting and using it as a service on a monthly based approach directly into your browser, submitting your computation over the network on your VPN or on the cloud. And this is also a novelty in the field because we are the first optimization platform that can be completely used by using the web approach, the software as a service approach, and this is a plus definitely for this new product. So if other questions are presented, I'm very glad to answer to your questions.
We did have one more question come in. What about the limits of Kimeme in terms of variables and objectives of my optimization project?
Okay, so thank you for the questions. I can move back to here the interface of Kimeme. So actually each one of these variable here in Kimeme is a vector or a matrix as well, if you want. So let's say a tensor. So actually you cannot say that in your problem you don't have, like in this case, two scalar variables, so just two variables, but you can say that, for example, one of these variables is an array of 100 variables. And we used Kimeme to solve problem up to thousands of variables, so very complicated optimization problems, and also several objectives, up to tens or even 100 objectives. Of course, with the objectives, the problem is a bit more complicated because you have to assess after the optimization which one is the most suitable solution for you. But by means of Kimeme, it is very easy to find the set of optimal solution and then make some data mining on your results to find your favorite result for your specific project. So actually you don't have much limitations with Kimeme. You can solve the so-called large-scale optimization problems.
Okay, awesome. Well, thank you so much. Great presentation today. And again, if you all don't mind just sticking around for a couple of minutes after we sign off and just filling out the survey, it's just a couple of questions. We would really appreciate your feedback. And we will be posting this webcast to YouTube, and we'll be sending the replay link to you in case you'd like to pass it along to your colleagues or watch it again on your own time. But again, thank you very much for joining us today, Ernesto.
Oh, thank you very much for your attention and for your time. And if you are interested in a demo of Kimeme on your specific project, or if you want an account to have a look at Kimeme online in the browser, please write an email to Saratech directly, and then we can actually keep in contact to arrange this demo.
Yep, absolutely. Wonderful. Well, thanks again, and I hope everyone has a wonderful day.
Thank you very much.